Let's pick up where we left off. Our next example deals with the volume of a cube. So let's think about a cube. It's a rectangular prism where all the sides are congruent squares. Now, to find the volume of a cube, we know our formula is area of the base times the height because it's a prism. But all the sides are the same. So I'm going to use S for the length of the side. This is S, this is S, this is S, everything's S. So the area of the base is sides squared. And the height is S, giving us S cubed. This is a special case when we're dealing with a cube. I know the volume. I know the volume is 512. So now I can find the side. So what I'm asking myself is, what number cubed gives me 512? Well, to solve for S, we're going to have to take the cube root. And most of you have a cube root button on your calculator, which would look something like this. Some of you don't have a cube root button. In that case, you have something that looks like this or like this. So what you would do first, typically, is plug in the 3 to say you want the cube root. And then you do one of these two buttons, and then you type in 512. We'll do a lot more with cube roots later when we talk about spheres. So if you're not sure how to find the cube root right now on your calculator, it's not so big a deal. There might be one problem that you're going to have to do this on. Well, the cube root of 512 is S. 8 is 8. 8 times 8 times 8 is 512. Okay, let me give you a minute to get this down. Now, just like we did with lateral area and surface area, anytime we're given the volume or we're given the lateral area, the surface area, what we want to do first is write down the formula. I'm going to go ahead and draw a picture for the people who are picture people in here. The radius is 4, and we're trying to find the height. Well, volume is area of the base times the height. So let's plug everything we know into this equation. The volume is 144 pi. The area of the base, well, the base is a circle, so pi r squared, 16 pi, times the height, which we're trying to find. Divide both sides by 16 pi. The pi's cancel, and 144 divided by 16 gives me a height of 9. Okay, let's try the same thing over here. This time we're given the height, and we're trying to find the radius. Once again, I'm given the volume, so I'm going to write down the volume formula and then plug everything I know into this formula. So 252 pi equals the area of the base. Well, I don't know the radius, but I know how to find the area of the base. Pi r squared times the height. Divide both sides by 7 pi. Well, the pi's are going to cancel out, and 252 divided by 7 is 36. So it looks like the radius of this cylinder is 6. Okay, these type of problems are a little different because we actually have two different shapes involved, two different 3D shapes involved. The first one is like a nut and bolt. And it's a square, well, a rectangular prism with this cylindrical section cut out. So this picture down below might help you see what it's going to look like a little bit better. These are like the problems we did finding the area of the shaded region. We have two volumes we're going to find, just like we had two areas we were going to find, and we're going to subtract them to find the remaining area, the area of the nut. So I have the volume of the prism, the volume of the cylinder, and I'm going to subtract. Well, the volume of the prism, area of the base, well, 9 times 10 is 90, times the height, which is 4, giving me a volume of 360. The volume of the cylinder, well, it's still area base times height, but this time the base is a circle, so we do pi r squared. The diameter, if you can't see that, is 8, which means the radius is going to be 4. So pi r squared would be 16 pi times the height. The height of the cylinder is going to be the same as the height of the prism, so that's going to be 4, giving me a volume of 64 pi. So my volume, the exact answer is 360 minus 64 pi. I could find the approximation by finding out what this is equal to and then subtracting the two. The next volume that I'm talking about is the volume of this thing that looks kind of like a toilet paper roll. So I've got a large cylinder, I've got a small cylinder, and I want to find the volume that's left when we take the small cylinder away. So once again, this is a subtraction problem. The volume of the big cylinder and the volume of the small cylinder. Well, let's see. Volume of the large cylinder is the area of the base times the height. The diameter is 10, so the radius is 5, giving me 25 pi, pi r squared, times the height. 300 pi. The volume of the small cylinder, well, the diameter is 6, so the radius is 3. Pi r squared is 9 pi times that same height, 108 pi. Now, I can go ahead and combine these because they both have pi's in them. So my volume is 192 pi. Okay, and our last set of problems are like the problems we did with lateral area and surface area. We are taking these rectangles and we're going to rotate them around the x-axis and then the y-axis, and we're going to compare the volumes. We're going to find the volumes of these two. So remember, this is our x-axis, this is our y-axis. So for this first one, let's rotate about the x-axis. So when we spin this, remember, just like we did with the last unit on lateral area and surface area, we get a cylinder. And the volume of the cylinder, area of base times height. Well, let's see, what's the radius? Well, the radius would be this 3 that we get when we're spinning around. So the area of the base is 9 pi. The height of the cylinder goes from base to base, so the height's actually going left and right on this picture. I get 6. So 54 pi is the volume of this. And once again, if we were talking units, we would be talking cubic units, so inches cubed or meters cubed, whatever the case might be. Okay, let's look at the second problem. Once again, I have this rectangle, but this time I'm going to spin it about the the y-axis. Now, does this volume look like it's going to be bigger or smaller or the same as the volume of the first one? What does it look like here? Well, let's see what happens. Okay, this time my radius is 6. So the area of the base would be 36 pi. And my height is just this little 3 right here. Multiplying those together, 108 pi. Definitely a larger volume than the first one. Actually, in this case, it happens to be twice as big as the first volume. Okay, so that ends the notes on volumes of prisms and cylinders. So your homework is going to be based on these. Use these notes to help you solve the problems.